So let's do another one of these examples where we find the power series for a function, but we're getting a little bit further away from the form that looks like the sum of a geometric series. So recall that what we're trying to do is take the given expression and put it into the form 1 over 1 minus box. And we don't really have anything that looks quite like that, but we should be able to do a little algebra and convert it to that. So here what we can do is we can say that 2 over 5 plus x cubed is equal to, let's work on getting it to this form. This number has to be a 1. It's not like 1 is sort of an example of a number it could be. This has to actually be 1, which means I'm going to have to take out, I want to take out the 2/5, and now I've got to rewrite that fraction. So the numerator becomes 1. The denominator is going to become 1, but I can't just put in x cubed because I can't multiply that by 5 and get the same expression. So I have to put in here x cubed over 5. You can stare at this and convince yourself that 2/5 times 1 over 1 plus x cubed plus 5 over 5 is the same as the given expression. That comes out to, I need to now get this minus sign to appear. So this is going to be 2/5 times 1 over 1 minus negative x cubed over 5. There we go. So, all right, so now what I want to do is now I have it in exactly this expression where this thing here is going to be, that's going to be the box. And I can simply just use some algebra to write this as 2/5 times, this is the thing that I can convert into a sum. So this is going to be the sum from n equals 0 to infinity of negative x cubed over 5 to the n. That's all I do. Once I've got it in the correct form, I can simply apply the formula. I do want to simplify this a little bit. So this is going to be 2/5 times the sum from n equals 0 to infinity of, I've got a negative sign raised to an n, so that's going to be negative 1 to the n, and x cubed to the n, it's going to be x cubed to the n is like x to the 3n, and then over that I've got 5 to the n. Now, keep in mind that if I have, let's say, 2/5 times the sum from n equals 1 to infinity of an, that's going to equal 2/5 times a1 plus a2 plus a3 plus dot dot dot. So that's the same thing as, like, I can distribute the 2/5 and bring it inside. So that would be like 2/5 a1 plus 2/5 a2 plus 2/5 a3 plus dot dot dot. So a simplification that I can do here is to bring that 2/5 inside, or at least it makes it a little bit cleaner. So that's going to be sum from n equals 0 to infinity of, this is going to be negative 1 to the n, or actually let's put the constant term outside. So it's going to be 2 times negative 1 to the n, x to the 3n over, just want to make that a little cleaner, over, I've got 5 times 5 to the n is 5 to the n plus 1. So that's really sort of the ideal way that I would want to see that answer. So there's that's the series that's equal to this expression. And where does it converge? It's going to converge for any place where x cubed over 5 is less than 1. That gives me the absolute value of x cubed is less than 5. Or finally, I can write just that the absolute value of x is less than the cube root of 5. That's really the correct way to write that. So it converges for all values of x such that the absolute value of x is less than the cube root of 5. This is where the series converges. This is, in fact, the series with a center of 0 for that function. So once again, what that means is that as long as I stay within this constraint, in other words, I'm talking about values of x that are between the positive cube root, that are between the cube root of 5 and the negative of the cube root of 5, then this series is going to be equal to this function. Outside of that interval, the function exists, but the series is meaningless. The series only has meaning within that interval.